Our company is introducing its new water bottle. This bottle is important because it will be eco-friendly, which means we won't use plastic to produce it. The other benefit this bottle has is that its height is only 10 centimeters long, so you can carry it anywhere you want and you won't have to buy another one, and you can help to reduce the plastic consumed.
Our bottle is actually designed to be held because if we look at the middle part, you can see that it's like kind of rounded. That's in order for you to grip it, or if you have something like a backpack to put it in the pocket, then you have this like cone form for the part where you will drink the water, and that's made that way so that your lips are ergodynamically put so you're able to drink water without spilling it.
So now, we're going to explain how we made the design of this bottle. First of all, the base of the bottle. It is made up by this curve over here, which is made up by the function f of x equals to minus 1/4 times x minus 3 over 2 squared plus 1.75 with a domain of 0,3. Then, the next step was to make an ergodynamic design so anyone could grab it easily. So we chose this little curve over here, which is defined by f of x equals to 1/2 times x minus 4 squared plus 0.71 with a domain of 3,5. Then we chose this one, this little curve over here, to join the ergodynamic curve with the rest of the bottle. It is defined by f of x equals to minus x minus 5.5 squared plus 1.48 with a domain of 5 to 5.5. Then the rest of the bottle is made up by this straight line over here with f of x equals to 1.48 with a domain of 5.5 to 8.5. So this is the largest part of the bottle. Then finally we chose this little line over here to make it easy for the customer to drink water from it, and it is defined by f of x equals 2 times x minus 8.5 to 10. And finally, here it is, the complete bottle with made as a piecewise defining function with all the domains and all the functions we have seen before. The whole bottle has a domain of 0 to 10, and this has been the design of the bottle.
Here we can see the piecewise defined functions all together in 2D and its parameters. So we turn the piecewise functions into a solid. Here you can see the frontal side of the bottle, but you also can see the bottle in different perspectives, like the left lateral side of the bottle, the right lateral side of the bottle, the superior side, the inferior one, and finally you can see the posterior one. I think that's all, and thanks for watching.
Piecewise defined functions are a very important part of mathematics. During this project, we'd use them as a simple purpose, which was the creation of a bottle. The process wasn't simple. We had to learn through correcting mistakes and repeating the process, but finally we could achieve a functional bottle. We had to make sure that there weren't any gaps between the lines, otherwise it wouldn't be useful as a bottle because there will be leaks. As we learned in this project, piecewise defined functions could be useful in almost everything, from designing something like our bottle, or helping us to calculate monthly expenses for a mobile data plan, or even to estimate the interest in an investment plan. They could be very handy when it comes to careers such as engineers, economics, design, or medicine. They are used when calculating the concentration of a medicine in a person's bloodstream. They can even save our life. The process to make the bottle was a little bit complex, because first we had to make a sketch of how we wanted our bottle to be. After that, we decided that our bottle was going to be used for the beverages industry. So it had to be practical, small, and cheap. We started to write the functions that we were going to use so the bottle could fulfill our needs. After all the functions were as wanted, we started to fix all the small flaws that were left. We adjusted the lines so they weren't touching each other at all moments, so there couldn't be any leak. And finally, our bottle was created.